Okay, what we're gonna do is we're gonna do problem 17 from chapter 2 in one more way. Okay, so in this situation, what we're gonna do is we're gonna look at the total ordering of all 25 people in rank. Okay, so you have your 25 people and you've ordered them um, in row or rank them from 1 through 25. Of these, 15 of them are women and 10 are men, just like we had before. What we want is spot number 17 to be the ninth woman that you see in ranking. So before that, in the first 16 spots, there should be 8 women. So since obviously there's 16 spots, so there'll be 16 minus 8, so there should be 8 men, and the 17th spot should be a woman. Okay, so in this case, what we're gonna do, earlier I just said, well, let's just concentrate on ordering just till spot 17 and not worry about this. But in this case, okay, let's just look at the whole thing. Okay, so denominator, that's easy. How can you order 25 people? That will just be 25 factorial. That's your whole sample space. Numerator, once again, we're going to do a similar kind of thing, but we're going to, at the end of it, add on how we order the remaining people in spot number 18 through 25. Okay, so first let's pick our 8 women to be in the first 16 spots. So that will be 15, choose 8. That how many ways we can pick 8 women to be in the first 16 spots. And 8 of the first 16 spots. And 10, choose 8 is the number of ways we can pick the men to be in the other 8 of the first 16 spots. Now we have these 8 men and 8 women standing around. We want to arrange them in the first 16 spot where order matters. So that will be times 16 factorial. So what have we done so far? So far we have the first 16 spots have 8 men and 8 women. And there's a particular order to them. Now what we need to do is in the 17th spot, we need to assign a woman. How many ways can we do that? There's 7 women left over, so you can pick any one of them. So there's just 7 number of ways to assign a person to that 17th, assign a woman to that 17th spot. Okay, now what do we have left? We have spots number 18, 19, 20, 21, 22, 23, 24, and 25. And we gotta take our 2 men who are left over and 6 women who are left over. So our 8 people, and arrange them in those 8 spots. Okay, how can you do that? That will just be 8 factorial. Okay, and you can see from the previous video, we had this 8 factorial in the denominator of the denominator. Well, exactly when you flip the denominator over, it would come over here. So it's exactly the same answer. You can very easily see that is exactly the same answer. But in this situation, we looked at orderings all the way from spot 1 through spot 25. But in the previous situation, I said, well, let's not worry about what goes on from spot 18 to 25. Either ways, if you worry about everything or you just look up to spot 17, both ways you will get the same answer because arrangements over here would just cancel out from both the numerator and the denominator. Okay, so I hope this makes sense. That's your answer to that problem. Okay, so what we're gonna do now is we're gonna look at a couple more problems. And one of them we're gonna do with a round table. Okay, so this is similar to a problem we saw in chapter 1. All right, so let's say you have delegates from 10 countries. Okay, And what you want is you want to arrange them in a round table. I think that's 10. Oops, I think that's 11. Okay, and the people are amongst some countries. There's France, England, the US, and Russia, and some 6 other countries. Now, what we want is that we want the French and English guy to sit next to each other. And we want the US guy and Russian to be apart. So we've done this problem where people have been seated in a row. But now what we have is a circular table. Okay, so how can we achieve this? Well, what we do is we think about how many ways can the French and the English sit adjacent. Not exactly how many ways, but let's look at all the number of ways in which the French and the English sit adjacent and divide it into 2 subgroups. One subgroup in which the US and the Russian are apart, and one subgroup is where the US and Russian are together. Okay, so you have the French and the English can, here you have that set over here is French and English guy together. Okay, and the whole sample space you've divided into 2. This is US and Russian together, and this is US and Russian apart. Okay, so you can see this set of French and English together, you can divide it into 2 subsets that are disjoint that union up to be this set. Okay, so how many ways can we have this happen? Well, that would be, so the number of ways the French and English together will be equal to the number of ways that the French and English are together and the US and Russian are together, plus the number of ways that the French and English are together and US and Russian are apart. Okay? And what we want is we're interested in that number. Well, this one's easier to calculate than that, and also this one's easier to calculate than that. So we'll calculate this, we'll calculate that, and take this number, subtract that from it to get what we desire. Okay, so how many ways can the French and the English be together? You tie up the French and the English together as one person, and now there are 9 people seated in a circular table. How many ways can you put 9 people in a circular table? Well, that would be 9 factorial divided by 9, because you could take all the people seated at the table and rotate them, and it would still have, if you rotate, if you tell everybody get up and move over by 1 seat, it's still really the same arrangement. So the number of ways that the French and the English sit together, it would be 8 factorial, because it's a circle table. If it was straight, it would be 9 factorial. And the French and the English were tied together, and now you can untie them, and they could be French to the right of the English or French to the left of the English, so you would have 2 factorial. So that's the number of ways you have the French together and the English together. Okay? And now let's look at this. The number of ways the French and English are together. That's one thing. And the US and the Russian are together. So you've tied those two together, tied those two together. So now what do you have? You have 8 people. How many ways can you arrange 8 people? You can think of them as one person each or one entity. How many ways can you arrange 8 people on a circular table? That's 7 factorial. French and English, once again, they can swap seats, one to the left or the other way. So you multiply it by 2 factorial. US and Russian together, once again, they could swap seats, and that'll be 2 factorial plus, and here is the required answer that we want. So we know that the required answer, that the number of ways that the French and English are together and the US and Russian are apart will be 8 factorial, 2 factorial minus 7 factorial, 2 factorial, 2 factorial. Okay, so this is with a circular table. In the book, the problem was with a straight table. Anyways, I hope that this explanation is clear about what's going on. Okay, all right. So you can rewind and look over any of the parts that you might need help with. And of course, you could simplify this some more. You could take out a 7 factorial and a 2 factorial. So this could be 7 factorial, 2 factorial times 6, because it'll be 8 minus 2. Okay, if you want, you could write that. Okay, all right. So next, what we're going to look at is we're going to look at problem number 39 from chapter 2. What is that problem say? There are 5 hotels in a little town, and 3 people are going to this town. Okay, so here you have, okay, and here's a bald guy. Okay, and they're gonna go to this town and randomly pick one of the 5 hotels. All right, the question says, what's the probability that they all 3 end up in different hotels? Okay, what's the denominator? How many ways can you assign hotels to 3 people? There's 5 choices for this person, 5 choices for this, 5 choices for this. So that's 5 cubed. And let's suppose they needed to get different hotels. Then the first person, or you can, let's just pick the youngest one to be the first person. And they're distinct people, so you can call anyone the first. You can have 5 choices for that person. Then second person, there's 4 choices, and third person, there's 3 choices. Or if you wanted, you could do 5p3, whatever you want to call the denominator. So what would this be? 12 over 25. That's the probability that all 3 of them end up in different hotels. Okay. Another thing I'm going to do is I'm going to take some of these notes from the review today and upload them so that you could take a look. Okay, so hopefully with these videos and the uploaded notes, you can understand whatever topics you might have had any kind of difficulty with. Okay, email me if you have any questions, and good luck. Bye.